Find the volume of the solid whose base is bounded by the graphs of y is equal to x plus 1 and y is equal to x squared minus 1, with cross-sections in the shape of equilateral triangles that are perpendicular to the x-axis. Well, in order to get started, let's actually start by drawing a graph of y equals x plus 1 and y equals x squared minus 1. Well, y equals x plus 1 is going to be a line. It's going to go through the y-intercept of 0, 1 and have a slope of 1. And x squared minus 1 is going to be a parabola that intersects the y-axis at 0, negative 1, and that's going to be the vertex. So our graph is going to look something like this. And we are creating cross-sections in the shape of equilateral triangles that are perpendicular to the x-axis. So since we're doing it perpendicular to the x-axis, a two-dimensional version would look like this. And if we were to rotate this to show that third dimension coming upwards, you can see the little triangles that are formed here. And since we're dealing with equilateral triangles, the area of an equilateral triangle is equal to the square root of 3 over 4 times b squared. And that comes from, you have an equilateral triangle. You would have a 1/2 of the base being this small section right here. And the height, using the 30, 60, 90 triangle rule, would be the square root of 3 over 2 times b. And the side length would be b there. If you multiply square root of 3 over 2 times b times 1/2 b, you get square root of 3 over 4 b squared. And now what is the b, or base value, in our situation? Well, we're going to take our upper function and subtract the lower function from it. So b is going to be x plus 1 minus x squared minus 1. If we distribute the negative through and combine like terms, it would then simplify to negative x squared plus x plus 2. That's what our b value is going to be. And now in order to find the volume, we have to multiply the area by the thickness of our triangular cross sections, which is dx. And we're also going to have to integrate. So we're going to have square root of 3 over 4. Our b value is right here. So we're going to have negative x squared plus x plus 2. And because we are, again, dealing with the area of an equilateral triangle, we have to square this. And we're going to integrate with respect to x. If we look at our two-dimensional graph to determine the lower and upper bounds, it will be from negative 1 to positive 2. Because we're at negative 1, and then the x-coordinate over here is positive 2. And we can pull the coefficient square root of 3 over 4 out of the integral. So we can rewrite it as square root of 3 over 4 times the integral from negative 1 to 2. And then if we do square this and combine like terms, we're going to end up getting x to the 4th minus 2x cubed minus 3x squared plus 4x plus 4, and we're going to integrate this with respect to x. So that's going to, again, simplify to square root of 3 over 4, and now let's integrate. We're going to have x to the 5th over 5 minus 1/2 x to the 4th, because 2 over 4 reduces to 1/2, minus x to the 3rd plus 2x squared plus 4x. And we're going to evaluate this from negative 1 to positive 2. And when we do evaluate that, we're going to end up having still the square root of 3 over 4 times, we'll have 32 fifths minus, if I put 2 in here, I get 16, and half of 16 is 8, so we have minus 8. Then we have another subtraction. If we substitute 2 in, we get 2 to the third, which is also 8. And then we can add, if we put 2 in here, 2 squared is 4, 4 times 2 is 8, again. Right, then we have plus 4 times 2, which is also 8. So this is one set from evaluating with 2, minus, now we have to evaluate it with negative 1. So we're going to have negative 1/5, because negative 1 to the 5th power is negative 1, put it over 5, and then minus negative 1 to the 4th is positive 1, so it's just going to be 1 times 1/2, so we have minus 1/2 there, minus negative 1 to the 3rd power is going to be negative 1, so that'll end up changing this to positive 1. And then we have negative 1 squared is 1 times 2 is 2, and then minus 4 at the end here. Okay, now I'm going to extend back over here where I have more room. We still have the square root of 3 over 4, and we have 32 fifths. Notice we have all of these, minus 8, plus 8, plus 8. They actually all cancel each other out, so we don't need them anymore. Then we have a minus negative 1/5, so that's plus 1/5. And then minus negative 1/2, that'll be plus 1/2. And then if we combine these terms together here, that'll be 3 minus 4 is negative 1, minus negative 1 is plus 1. So plus 1 here, and we can get our common denominator of 10 in the parentheses, so we'll have 64 over 10 plus 2/10 plus 5/10 plus another 10 over 10. So we're going to end up having 81/10. And then when we multiply these together, we get 81 times the square root of 3 over 40, which is answer choice D.